Hey, what's up everybody? Welcome back to my channel. Salman Iqbal here. You can follow me on Twitter at SolmanIqbal, trainer at LearnK8. On this channel, we'll be talking all things cloud native. I know what you're thinking. So far on this channel, we've only talked about Kubernetes. Rest assured and subscribe to this channel and there's lots more coming. In this video, we're going to be talking about how to isolate a pod in Kubernetes and how we can use some techniques to debug the pod live in production. But before I can talk about that, let's clear up some concepts, as some concepts can get a bit confusing. We have pods, services, ingress, container port, target ports, match labels, selectors, ports, donuts. Okay, maybe not that. What do they all mean? Let's check it out. Let's start with a pod. And in this pod, we are running our container. The container is a lovely static page with an alarming red color, and our user Dan would like to access that page. There are a few things we need to do between the user and the pod in order to route the traffic to it. We have to add a service. Service acts like an internal load balancer and keeps track of where the pods are. Our user is sending traffic from outside the cluster. Perhaps we need something that is a bit intelligent that can route the traffic to various services based on the request. For this, we can use an external load balancer. In Kubernetes, we call it an ingress. The container is running a website, so it has to run on a given port. In the pod, we define the port the container runs on as container port. Now the service has to route the traffic to the container port. It has a property called the target port. And as the name suggests, this should hold the port value the service needs to target, i.e. the container port. So what that means is that target port and container port should match. So if the website is running on port 3000, the target port should also be port 3000. These are container ports and target ports. And how do we define them? Well, we define them in, you guessed it, YAML file. This is a normal deployment file. It tells us how many replicas we're running, the image that's running, and the container port itself. And in this case, we have set the container port to be 3000. What about the target port then in the service? How do we define that? Let's look at yet more YAML. This is what a service YAML looks like. We can give service a name. In this case, we called it red, and the target port should be 3000, as we said before. And service itself has a port. Let's say we assign it port 80. Now the service itself is running on a port, and we need to do something to move the traffic from the ingress down to the service. So just like clockwork, the ingress itself has a service port. And you have probably guessed it by now, the service port and the port needs to match. In this case, we set both to 80. And how do we define them? Yes, in Ingress YAML, of course. This is what our Ingress file looks like. We are mainly defining rules for any of the requests that are coming in. If a request comes into our path, let's say /red, route that request to service named red, which is running on port 80. And as if by magic, your request from the browser will end up in the service. The aim of the service is to send your request further to the pod. Service already knows what port the container is running on. However, there is one more thing it needs to know before it can send traffic to the pod, and that is to do with labels. For pods, we can have labels, which are arbitrary key value pairs. In this case, we have picked app equals web. This can be anything else too. For example, you can say environment equals prod. Where do we define this label? You've probably seen it before in the deployment file. There is this section, the match label. That is where we put the app equals web label. You can have multiple labels. Now the service needs to know about which pod it is selecting based on the label, and it has a selector property, which is set to the same label as the one on the pod, app equals web. So not only the ports have to match, the labels and the selectors have to match too. And we define this in the service YAML. You can see we have a selector block, and we have written in there the label we want the service to target. These labels have more to them than just forwarding traffic to one pod. Perhaps you can start to see how we can utilize the labels to send traffic to multiple pods at the same time. So once we set all of this, the traffic flows from the user to the pod and we have one happy customer. Let's say we have another pod, and instead of being the red page, it is a yellow page. And you want to test out this yellow page on some users. Right now, all traffic is going to the red pod. But what we can do, add the same label app equals web to the pod. And what that does is that it allows Kubernetes to attach the yellow pod to the same service. And we start sending traffic to it. So some of the traffic will flow to the red pod and some of the traffic will flow to the yellow pod, and we can monitor what we want to monitor. Now that we know we can use labels to route traffic to particular pods, let's see how we can use these labels to isolate pods when they're running. Let's say we scale up our deployment to 3 replicas. All of them will get the same labels as they're part of the same deployment. I've removed the ingress from the diagram to make it less busy. We will just have to pretend that it's there. Because of the label and selector, the traffic starts flowing to the rest of the pods as well. Now imagine pod 1 has started playing up and you would like to not send any more traffic to it and perhaps debug it. What we can do is modify the labels. The quickest way to do it is to run the command kubectl label pod 1 app equals debug -- override. You can also edit the label in YAML file and submit it to the cluster. Both have the same effect. We can see now that we have a new label on pod 1, and now two things will happen. First, the service stops routing the traffic to the pod because the service selector does not match the label of the pod. Then the replica set, the thing that keeps an eye on replicas, notices that there are only 2 replicas, but you asked for 3. The replica set creates a new pod. So now we still have 3 pods that are receiving the traffic, and we have our problematic pod which is on the side and we can debug it. And there are a number of ways we can debug this pod. We can either use kubectl exec to get a shell to a running container, or we can use kubectl port forward to forward traffic from one of our local ports to a pod for debugging. Or we can add a debugging container using kubectl debug. I have added details on how to use them in the description of the video. So in summary, we need to make sure the target port and container port match, including their labels. The service port and ingress port on the service should also match. And we can modify the label on a pod to remove it from the service so no more traffic is sent to it, and we can debug using various techniques as discussed. I hope that gave you a bit more understanding on how labels, selectors, and various ports and all these services, ingress and pods work, and how we can route traffic using those things. If you'd like more details on this topic, I've included links in the description for you to check out. If you'd like to see more content like this, please consider subscribing to the channel, sharing it with your friends and colleagues. Until next time, thank you very much for tuning in and stay safe.